Hello? So this looks like a study. When we speak about repeatability of the device, most of the time is an extremely boring topic. What I'm going to show you is that in this case, how much the repeatability is relevant for you, but particularly what I will show you is how it will improve your clinical practice. So I will make it extremely into clinical practice. So first of all, as an introduction, we know that detecting keratoconus, but particularly detecting the progression, is a major concern for everybody. Most published data, and I include myself, we have used 1 diopter / 1.5 diopter as a change of to the side cross-linking. And that is based on axial map. I don't know if you are aware, but the 1 diopter Kmax, except in the CSO platform, which is smarter, it's based on the maximum keratometry of the axial map, which by definition is the wrong map for keratoconus. So starting this, Kmax is incredibly variable, particularly in moderate to advanced cones. It's a single point, so you have frequent false positive and false negative. The global consensus of keratoconus and ectatic disease, and now we are actually doing the new version, so we are actively doing now and part of the coordinators of the global consensus, but the first one was saying, if you want to detect progression, you have to see, and I'm going to read it word by word, combine parameters from both anterior and posterior cornea and corneal thickness to determine the inherited measurement of noise and whether there is a statistically significant change. So this is super complex. So how do we define progression then? Let's read again. We have to combine parameters first. We have to use anterior, posterior, and thickness, and then noise level. But what noise level mean? Let's make it simple. I am 1 meter and 81 centimeter tall. So if you measure me now, and then I move here, I'm not anymore 1 meter and 81. I will be 1 meter, 81, and 1 millimeter. Do you think I'm taller between here and here? No. That is noise. So when you want to know if Riccardo is actually taller, you want to know how much is the noise measurement. And if it is higher than the noise measurement, then I'm taller. That's the same thing for keratoconus. So how do we define measurement? It's extremely simple. You measure a patient 3 times. You measure the noise level, and if it is above the noise level, eureka, then it's a significant change. So is 1 diopter Kmax too much, too little, just right? Is there anything that can make our work easier? So the first thing was done by Oculus platform. I think they actually did a great display in which they used the ABCD progression display and they put noise level. That was really important. The ABCD progression display, it's widely used and now is also available on the CSO platform. I published a study some years ago in which I demonstrated that half of the patient that we included for cross-linking with the national health system, that by definition in Italy, unfortunately, is 1 diopter Kmax change, blah, blah, blah. So imagine that you have some of these patients that instead of coming twice, because they had 1 diopter Kmax change, before they came another time and they had, I don't know, 0.6 Kmax change. But I had the pentacam. At that time, I didn't have the MS-39. So I had the pentacam, and I measured that half of that patient were already progressive before. So what do we do now? We have excellent platform with multiple indices, and we can also average the scan with the MS-39. So this is what is available now, so in May 2024. So this is a display that is able to show you difference in indices, and maybe you don't know, but you can also average the scans. So you can put more than 1 scan, and it will give you the mean and the standard deviation of that particular data. Second question, does one size fits all? What does it mean? Let's go back to Riccardo, 1 meter, 81 centimeter tall. So imagine that I'm tall 2 meters and 30 centimeters. And somebody of like that is this tall has to measure myself. I'm sure that he will have or she will have to jump to make a measurement. Is it going to be more noisy compared to me? It's going to be more noisy. So it's the same thing for keratoconus. If you have an extreme keratoconus, it will be noisier. So when you buy the Oculus platform, you have 2 gates in the ABCD platform. There is one green gate that is for normal patient. I'm speaking the users meeting of CSO, and I have no financial interest with CSO, but I am a consultant for Oculus. And I told them hundreds of times that didn't make any sense to have a green gate and a red gate, because the green gate was for normal patient. And I was saying, you are showing a keratoconus progression display and you have a noise level of normal patient. Why? So but regardless of that, they were saying, well, if you have an early keratoconus, then you want to use the noise level of normal patient. If you have a keratoconus, then you use the keratoconus noise level. To me, this inevitably doesn't make any sense. You should have a noise level for early, moderate, and advanced keratoconus. But regardless of that, you can see that the noise level is incredibly different, and this is A, B, and C. So this is the noise level, the confidence interval for A, B, and C values in the platform. You can see that between normal and keratoconus in A value is 4 times more. We are speaking about 4 times. It's incredibly more. But even when we speak about keratoconus, this is not true, because Gustafsson, that they made an incredible work, they showed that if you have a patient with clear keratoconus, so I think that we all agree that a patient with 49 diopter of Kmax is most likely a clear keratoconus. It's not like early, it's clear keratoconus. So imagine that you have this patient and you use 1 diopter of Kmax, that is too much. So this patient is already significantly different with the pentagram. I'm going to speak with the MS-39 later, and there is a reason, with 0.65 diopter Kmax change. So that's too little. If you have a patient with more than 49 diopters, then 1 diopter is not enough. You need 1.4 diopter Kmax change. To me, this is already quite disturbing, that we use one cutoff that is basically always wrong. So if they are, early is wrong. If they are advanced, is wrong as well. So we did a study. We wanted to evaluate the repeatability of indices used in keratoconus and to develop a simple way for you to detect keratoconus. But if you want to do a good study, you need friends. So we asked for help, and we wanted to gather the data all together to create a big database. So this is a study that we did all together. I'm speaking here at the podium, but they should all be acknowledged. So, doesn't work. Okay. So basically, we had about 1,366 eyes. We also had patient after cross-linking, and I'm going to speak with you why. And we created noise level. So we measured the patient 3 times, and with this, we were able to create the noise level. So let's start with results 1. That we had good repeatability. So this is very statistical. I'm pretty sure that you're not interested in this slide, but I had to show it because it's, it's science. And now I'm going to show you like real practice. Okay. This is the results of the Kmax. You're not interested in this, but you're interested in this. So you remember I was telling you that a patient with more than